Well, hello friends. Welcome back to Browser Hacking. Today, we are going to continue working on Discord support in the Serenity OS browser. And there are some performance problems I'd like to look into because we've gotten to the point where we can load the basic invite page for the Serenity OS server. But when you try to type into the username field, it's extremely sluggish. And normally, I like to ignore performance in favor of focusing on correctness early on for something like this, but there comes a point where performance is so bad that you have to do something. So if you see here, when I type into the username field, the text is actually black, so it's a bit hard to see, but I'm typing and now I'm waiting, and now the characters show up. So I'm going to type XOXO, and then we wait. And there they are. So very, very slow. You can see the CPU spiking when we're typing. So the goal today is to profile, figure out what this, what's going on here, and then try to optimize away the problem somehow. Hopefully we're doing something stupid that would be easy to just not do, but we may also have to get clever. We'll see. Once we get a profile, we'll have a better idea. So first thing we're going to do is we're just going to record myself typing here a couple of times. Just doing a few bursts of 3 characters. All right, there we go. And then we will save that profile and open it up. All right, so we see time is very heavy in the web content process. I think probably this is a burst of 3 characters right here, another 3 here, and another 3 here. So I guess let's look at the middle one maybe. What's happening? So switch to percentages and top functions, and then focus on web content. And what's happening in handle key down? Okay, so we're inserting a character, which forces a layout of the document, which means that we have to start building a layout tree. Okay, so I guess we're doing I think probably inserting text into a text field is relayouting the entire document. That's probably not necessary. I mean, it's definitely not necessary. We can do less of that, like lay out just the part that we need to lay out, like the little miniature DOM tree inside of the text element or the input element. But either way, like, why is layout so slow? You would think that with a relatively simple document, the Discord page is not that complex. At least not the invite page. Once we log in, it's going to get more complex, of course, but you would think that this page here, if we look at the DOM tree, it's really not that bad. Like, we got some SVGs, and then we got this little thing in the middle, but nothing crazy. So why is that so expensive? Well, it's recursive, as we can see here. So a lot of recursive tree building. So I guess I should describe how we build the layout tree. What we do is, if we have a DOM tree that looks like, let's imagine we have a DOM tree that looks like this. And then imagine the corresponding close tags and whatever. But let's look at it that way. What we do is we start here and then recurse down through the tree, constructing a corresponding layout node or a box tree node for each DOM node as we go, if they have a CSS display other than none. So CSS display none does not get a layout tree node, but other display types do. So this would become something like a block container, probably the same thing here. Same thing once again. This one will become a layout inline node, and this here will become a layout text node. Yeah, so this is what we're doing here. When we do a tree build, so layout tree builder build, this is effectively what it does. It traverses the DOM tree, figures out what type of layout node should we create for each of these DOM nodes. But in order to figure out which type of layout tree node we produce, we have to first figure out what is the CSS or what is the style that applies to this element or to this node. And to do that, we have to run the big old CSS machine. So at each step of the way here, I would imagine we should see the style computer doing compute style. So essentially the way create layout tree works, if you look at it, is that so this thing is called recursively, but basically if we are creating layout tree for a DOM element, then we will ask the style computer to compute style for this element. And then if style display is none, then we stop recursing here. We don't create layout nodes for anything that's display none or any of its descendants. And then further down is where we would recurse down here if this DOM node has children. But compute style here is done every step of the way. So we have to run the CSS machine on the selector engine we run on every element as we go in order to figure out what type of a layout tree node should this have. Yeah, so you can see compute style here at every step of the recursion. And it looks like the create layout tree itself doesn't actually take much time. Time is rather spent in compute style. So since we are in top functions view, if we scroll down a bit, we can probably find compute style as a top level item right here. So you see we have 82% or 82.8% of runtime is in compute style. So that's very, very heavy on this page when you're typing. And I bet you it doesn't have to be. So let's just open that up. We can see here that there are two things happening. We are traversing all of the style sheets in order to traverse all the rules, in order to run the selectors of each rule against every element. And then we are also performing the CSS Cascade, since the C in CSS is for cascading. And in the cascade, resolving unresolved style value is apparently 100% of samples. So seems like custom properties. Oh, so they're using a lot of custom properties here. Okay. And resolve custom property is half of expand unresolved values, and the other half is calling itself recursively, which then eventually bottoms out in resolve custom properties. Okay, so this is all custom properties. So the CSS style computation, the cascade part at least, which is actually most of it, 99% or something like that, is divided between style rule traversal and expansion of custom properties. So we can definitely improve something here, I think. I have not looked much at the custom property code. Actually, we can see it here. Resolve custom property is 34% of total runtime. So quite heavy. And actually we should take a look at the actual style sheet. So let me see here. I guess this is the one. Let's just wget that. And it's 1.54 megabytes of CSS. Wow. Yeah, I don't know what I was expecting. A lot of CSS. Let's put this into a CSS formatter or something like that. because I guess it's minified or something like that. I would like to have a maxified version of it. Oh, wow. This thing is not happy about opening such a large file. All right, pasty. Wait. Oh, I could just paste the URL directly into this page. Should have just done that. Okay, load URL. Here we go. Okay. Paste. And we'll save that as discord.css. Cool. So what are we talking here? We're talking 81,000 lines of CSS. Lots and lots and lots of rules. So this looks really heavy. So whatever we do, where are all the custom properties? Okay, yeah, so they're using CSS variables a lot. Presumably they have a root element with lots of stuff. No, just the fonts. Okay, well. Oh, here we go. Okay, so they have a CSS class called theme dark. Then it defines a whole bunch of variables. And then whenever we compute the style for something, we have to go and resolve all these variables. And that's taking up 34% of our time. So I think we can improve that probably. And then the fact that this is just a gigantic style sheet, I think we can probably, or we can definitely do something about that as well. We should be able to reduce the number of rules that we have to evaluate for each element if we do a little bit of pre-processing of the rules. So this is something I worked on a lot in WebKit back in the day. So I definitely know a whole bunch of techniques we can do to sort of limit how many rules we have to look at for each element. Because right now we have to look at, well, right now we don't. Right now we do look at every rule for every element. So imagine that you have like 10,000 rules in this document. And then you want to compute the style for 100 DOM nodes, let's say, conservatively. So that is, of course, a million rules that have to be evaluated, or selectors that have to be executed. And in fact, it looks like the majority of these rules are simple class selectors or class descendant selectors. But classes are extremely common. So imagine you are evaluating, or you're trying to figure out the style for an element, and the element has, say that it has no class attribute. You don't have to look at this rule, right? If you had a list of rules for each class, you could easily skip over rules that you're sure are not going to apply because you don't have that class. So I think we'll do something like that. We'll add a, we'll sort of add a rule cache and divide our rules into buckets. So we have like a bucket for each class, a bucket for each ID, something like that. And then we can have another bucket for everything else. Actually, this page doesn't seem to use IDs. So it's like all classes. I mean, I'm just looking at a small sample, but I haven't seen any IDs. Search for, yeah, it's all color hashes. Anyway, okay, so two things to do here, I think. So we want to bucket our rules so that we only run the necessary rules. And then we want to figure out why custom property expansion is so heavy. So let's start with custom properties. What does resolve custom property actually do? Also, let me let me refresh myself on how custom properties work. CSS custom properties. Okay, how do you use them? Okay, so this is how you define a variable, I guess, or declare, and then you use it in this way. Yeah, right. So let me make a little test here. If I just turn on HTML preview. So let's do div. Okay, so actually, so I would declare a variable here. Foo is red, and then in the inner one, I would say background bar foo. And then I guess I have to give it some height. Yeah, there you go. Okay, right, so that's how you do that. And then how do we expand these, and where do we expand these? Resolve custom properties called by expand unresolved values. Expand unresolved values is called by resolve unresolved style value, which is called by cascade declarations. Okay. And the cascade declarations is called, I have to reacquaint myself with this, with compute cascaded values. Oh yeah, right. So this is our implementation of the CSS Cascade, which determines the order in which you have to evaluate all of the CSS rules for an element. So this is the order right here. Let's see. So I guess we do them backwards. This is the precedent. So these are like the most important are at the top. So we start with the least important ones. So we start by applying all the normal user agent declarations, normal meaning not important. So this is user agent, presumably important false. Yes. Maybe we should have a, let's do a quick change here. Important. I want to make an enum for that, because that was a bit annoying to read. No, yes. Okay. Bool important. Oh, wait. Oh, it's stored as a bool here. Oh, that will propagate so much. Okay. Maybe I will just ignore this for now. Let's not, okay. I shouldn't have gotten carried away with that little thing. Let me backtrack. All right. Ignoring that, cascade declarations is called multiple times. So we call it once for each of these steps here. Although I guess we're probably skipping the animation and transition steps. Yeah, just fix me's. But before we can cascade them, we have to actually collect all the matching rules. So we collect all the matching rules from the user agent style sheet. This is the default CSS that comes with the browser. And then we also collect all the matching rules from the author style sheets, which are sort of the style sheets attached to the page through style elements and link elements. Okay, and then we sort all the matching rules by specificity and also document order. And then we apply them. Okay. So during cascade declarations, we have to resolve unresolved style values. What is an unresolved style value? Is unresolved. Added by Sam, who said, add new unresolved style value class. This represents a property value that hasn't been converted to a proper style value yet. That is, it's either a custom properties value or a value that includes var references, or both. since neither of those can be fully resolved at parse time. I see. Okay, yeah. So because we can't figure out in the parser, in the CSS parser, what these values are going to be in the end, we save them, or the parser produces an unresolved value, and then it's up to the style computer to actually resolve the unresolved value into something more tangible. So that's the job of this function. That makes sense. Okay, so it's just going to return a replacement value for that property value. Okay, and then this guy is just told to expand unresolved values, and then we parse the expanded values, it seems like, if that succeeds. Okay, and then expand does what? Expand, fix me, do this better. All right. What does it do? I guess it just traverses the internals of the unresolved value and expands var uses. So get custom property, this lambda here presumably is used. Yep. Okay. So this guy calls resolve custom property. And then when we want to resolve on, we ask the element to resolve the custom property. That's weird. Why are we asking the DOM node? DOM node doesn't know anything about CSS. Okay, so DOM elements have a custom properties hash map. Why does DOM element have a custom property hash map? So if the property is in the element's custom property hash map, then we just return that. Otherwise, we do stuff. Oh, maybe this is just a cache that hangs on the element. So like after you compute a custom property for an element, then you hang that on the element so you don't have to recompute it. I guess that's probably what this does. So here's add custom property, which inserts something into that map. And who calls that? Add custom property. We are in resolve custom. Oh yeah. So right below here. Okay. So the first thing we do is we just check if we have a cached resolved custom property for this custom property name for this element. Otherwise, we compute it and then add it to the element. That makes sense. Okay. Maybe if I had blamed it, I would have read something like that. Let's see. So Tobias, improve performance of CSS custom property resolution. By memoizing already resolved custom properties in the DOM element, we achieve a notable speed increase when loading Serenity OS on GitHub. Okay, so yeah, that's exactly what he says right here. That's what it's for. It's just a memoized cache. Fine. Maybe long term we shouldn't hang that on the DOM element because it feels kind of awkward to put CSS stuff in the DOM if you can avoid it. We can probably find a place for that cache somewhere here in the style computer. But for now, we can let it be. Okay, so then what do? We figure out, do we have a parent element for the element we are resolving a custom property for? If so, we resolve custom property. We resolve the same property for the parent element. Okay, so I guess that means we will recurse up the chain of parent elements. Every time that we resolve a custom property, we will recurse up the chain of parent elements and resolve the same property there. And why? And then what do? We collect matching rules. Okay, this is not cheap. This is very not cheap. So what is that for and how expensive is it exactly? So we are in resolve custom property with specificity. So this guy right here, spends 160% of time. It seems like we have some kind of a math bug here in the profiler, but we can see that it is, let's switch to, or no, we don't have anything to switch to, but we can see that it's calling itself recursively, right? So a lot of recursion. And then the other thing it does, it iterates across all the style sheets. I guess that's probably this guy right here being inlined, because what he does is for each style sheet. Yeah, for each style sheet. Oh yeah, and you can see that it's for each style sheet with a lambda from collect matching rules. So collect matching rules totally dominating this function. Right. Okay, and then what do they use that for? Or what do we use that for? We collect all the rules that match for the element, which we already did earlier. So now we are in resolve custom property. If we look at where we started in compute style, we decided to resolve some unresolved style value. We want to expand unresolved, resolve custom property. And then right here, once we get into resolving one custom property, we end up doing a bunch of collect matching rules. But collect matching rules happened earlier at the start of compute cascaded values. So right here, we have found all the matching rules for the element. And now we go and find them again for every custom property and also for every parent element, going up to, for every parent element, ancestor element. So anyway, there's going to be a whole lot of collect matching rules happening. And that's work we've already done. So we can definitely find a way to avoid that. Yeah, that's what we need to do. So how do we avoid that? Collect matching rules. What do they do with the rules? What do we do with the rules? We iterate them backwards. Okay. And then we look for, if we find a rule that has a greater selector specificity than what we inherited from our parent, I guess, then we override it. Oh, so this is like inheritance mechanism that respects selector specificity. Oh, okay. Yeah, this is a functional but extremely expensive way of doing that. I think we have to rewrite the way custom properties are resolved. So instead of doing it this way, what we should do, I think, is like at the start of the cascade for one element, we would start by computing all of the final custom properties and then just putting them into a hash map. And then we can pass that hash map down the line so everybody can just fetch the final value of each custom property from that. It will still be more expensive than, like, if nobody ends up using any of the custom properties, then we did waste time computing them. But it should still be substantially less expensive than what we're doing here. So let's see how we would write this. Cascade, compute cascaded values. Okay, so at this point, first we find all the matching rules, and then we have to extract all of the custom properties from these rules. And we know that our user agent style sheet default.css does not use custom properties, I think. I mean, in the future it might, I guess, but I don't think we should. But we mostly have to be, or we really only have to be concerned about author rules, right? Stuff that comes from the web page. So let's focus on that. So then we resolve all the CSS custom properties variables. for this element. Okay, and then how do we do that? Cascade variables, let's say. And then it's going to be a string to something cache. What did we cache on the element? We cached custom property resolution tuple, which is an optional style property and a specificity. Specificity. I think maybe we don't need the specificity if we don't, like if we resolve everything up front, and I think we don't need to remember the specificity of each custom property. I think we can probably get away without it. So we should only need the style property. And in fact, we could probably use style property star and then just point into, because this is all a temporary thing on the stack here anyway. And we already have all the matching rules. So I think we can point into that instead of making copies, at least. Because this is a fairly chunky boy with some stuff here. So taking advantage of already existing storage seems reasonable. And then it can probably be const as well. Okay, so let's call this custom properties. And then let's refer to them as custom properties, right? Or what are they actually called? Are they variables or custom properties? Custom properties, variables in parentheses. That's great. Which is it though? What's the official name? Come on. Let's see the speckity spec. See, this is variables spec, please. So there's CSS variables from 2012, outdated, sure, forget about that. And this is CSS custom properties for cascading variables. Aha. Well, the spec is called CSS variables, but it's custom property. Why couldn't they pick one name? All right, let's just go with custom properties. Since I think that's what's used elsewhere. We don't have CSS variable anywhere, but we do have CSS custom property. Yeah, let's go with custom properties. So we want to cascade all of the custom properties from the author rules, let's say, into the custom properties hash map. Cascade custom properties. What's this? It's a vector of something. Why can't I get to it? Author rules. Vector of matching rule. Okay. Right, so we have a vector of matching rule. Matching rules. And then we also have a hash map of string to style property const. And this is our custom properties. Okay. So we just have to iterate all the matching rules. So matching rules. And then how did we resolve these previously? In Cascade declarations, we're iterating the matching rules and we check for any property that's unresolved. We call resolve unresolved style value on it. But that we still have to do. Oh, yeah. That's because that's not what we want to do. So how does this one figure out? Wait, how did we figure out what the custom property was? Here. Right, so we're asking the rule has a declaration, and that declaration has a set of custom properties that you can query. Here we go. So this is a CSS style declaration. Property owning CSS style declaration has a hash map of custom properties. Fantastic. Okay, so that's the thing that we want to extract from. I think we're going to borrow this huge line of code here. So cascade declarations. No, compute cascaded. So matching rule. Custom properties. So we want to get all the custom properties. Okay, and then custom properties set it key and at it value. Does that work? I'm pointing right into it. That's really cool if this works. Okay. And then how do we inherit from the parent? And how does the parent inherit from its parent? Because we don't want to walk the parent chain. We want to just, if everybody just starts with the custom property, the resolve custom properties that we resolve for the parent, we just start with those. So first thing we do is like custom properties is, or if element has a parent, then we take, can we take all the custom properties like that? I guess we can't just copy them because that's this weird tuple type. So, okay, but that's fine. We can iterate them. So then we'll use the cache on the parent element and just extract all of the properties from there, put those in our local thing. So set it key, it value, style, value, dot, like that, like that. Okay. Yeah, so now we have to make sure we populate the parent cache. And this should work because we always do this top down. Like we start at the root of the DOM tree and then we work our way down. So you will always have resolved the style of a parent element before you resolve its children, which means that it should be safe to query anything cached in the parent at this point. Okay. Yeah, so we start with everything inherited, seed the custom properties with that, and then get run the cascade. And the reason that the cascade will just work, why will it just work? Because we have already sorted all the matching rules by specificity. So this is, yeah, so what we're going to do here, we're essentially just plowing through all of the matching rules in order of specificity already set up for us, and then yoinking all of the custom properties every step of the way and copying them over. Man, this would be really nice if this works. So let's see. And then what do? We just have to pass this in to Cascade declarations, I think. So if we pass this along and allow, and then we pass it along to resolve unresolved style value. const custom properties. Yeah, let's just go ahead and fix up the declaration here. Okay, so we're going to pass that in. And we have to pass it into, where else do we have to pass it into? I already forgot. To resolve unresolved style value. Right, resolve unresolved style value. Which probably calls expand right after, but let's see if it does. Resolve unresolved, sure. Right, so we have to pass it along to expand here. Oh, it has a default argument. Oh, that's a little bit annoying. Okay, I guess let's get rid of that default argument and then also pass the custom properties. So here we'll just hardcode 0 and then pass our custom properties. And then I think we can use CLion's problem view here to find what to do next. So here we go. And then it's unused, sure. And we just have to pass it along in a bunch of places. Oh, I was missing the 0. Okay. What am I forgetting now? I guess we also, wait, how do we make sure that things get cached? Expand unresolved values. It still calls resolve custom property. Okay, yeah, so this doesn't actually get used yet, but I think we can delete this thing now. We just have to remember to update the element cache. So we don't need resolve custom property anymore. I think resolve custom property, because what we can do here instead is just capture the custom properties. And then look in the custom properties, find name. And if it is not custom properties.end, then return it value. Almost. What am I looking at here? Oh, I have to dereference that to give you something else. What was it called? Value? No member name value in entry. Okay, what is in the style property? It has value. Okay. What is this thing? This is going to be a style property const star. Value. Okay, there we go. Oh, I couldn't do that? Yeah, sometimes I get messed up with these, like which way to dereference iterators. It can be a bit, it's not my favorite thing about C++. Right, so resolve custom property, blah, 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 can go away. And we just have to remember to do this part right here, where we set the thing on the element. And then we have unused lambda captures. Sure. Then we don't have any errors left. So let's look at compute cascaded values. After we cascade all the custom properties, we have to assign these to the element. So I guess custom properties. Can we clear this? We really want to clear this map, first of all. Let's just add a mutable accessor here so that we can clear it in case there are cached old properties that are no longer relevant to this element. Let's just nuke them and then copy over all the custom properties here. So element add custom property, it key and it value. And then I think we can nuke the special type used here, custom property resolution tuple. And this can instead just be a plain style property. Yes, and we'll move. Can we double move actually? Move. Then we just have to change the type of this thing. So style property. And this is optional property. But who uses this now though? Resolve custom property. Nobody actually calls this. So let's get rid of it. That's probably okay. Okay. Will it build? Who knows? No member named style in style property. So instead, this thing is now just a plain value, which we can take the address of. Yes, taking the address to a custom property in a parent element is fine because we've already resolved parent style at this point, and it's going to be sticking around. Yeah, that's a good thing about going top down here, is that we can count on ancestor elements in the DOM having their final style computed before their descendants, which would otherwise, it would be very tricky otherwise. Like if we would go and try to like go in any other direction, like bottom up or something like that. Let's see. I wonder if we should probably move this out to a helper function. Cascade custom properties. Maybe all of this should be in a helper. For element. Let's see. DOM element. Then we can even do this. Custom properties is that. And then we will return that instead of taking it. Yeah, that feels slightly nicer, because then all of that cool stuff can live in there. Okay, and then what the heck is this? Web content client connection. Why does he know about custom properties, I wonder? Maybe the problem view will tell us, yes. Serialize custom properties. Why do we have that? Oh, dude, you can look at these in the inspector, right? Of course. Of course. So I guess we just need to update the traversal code here because it doesn't care about the specificity that we were storing anyway. So value, what is the value now? What is property? Is it an iterator? Okay, and then it stores style property, and style property has value there, right? Scene properties, set property key, sure. This is a weird way to iterate. Let's call that IT. Contains and set. Actually, you know what? I'm going to touch this as little as possible, but we can definitely do like fewer hash lookups and stuff like that here. Let's not get carried away with micro optimization nonsense for performance irrelevant code. Or at least until we measure it, it's performance relevant. So, all right, moment of truth. It builds, but does it work? I guess we'll just go to Discord right away and see if it loads the page at all. That would be really nice. Well, okay. Despite that little paint slowness, it actually works. That's cool. And what if we try to type here? It's still slow as heck. I don't know if it's much faster. Let's take a look. Anecdotally, it feels a little bit faster, but it's obviously not acceptable yet. So, oh, dang it. I have to close that. Not enough memory in this VM to have the browser up on Discord and the profiler at the same time. Web content. All right. And then here are some of my 3-character bursts. Let's just sample a bunch of them. And also percentages, top functions. Okay, what's the breakdown? So we have compute style, 83%. Compute cascaded values for each style sheet, blah, blah, blah. Okay, and here's that. This is a function that computes the cascaded values. Let's see. Yeah, that's custom property helper thingy that we made. Cascade custom properties. It's like 1.3%. That's how much it costs us to figure out all the custom properties now, which is really good. But in the great scheme of things, it was less painful than I imagined it would be, I guess. Because we're still spending so much of our time running all these selectors. Right. Okay. Well, not to worry. Guess we'll have to start filtering the selectors then. So I was hoping this would help more, but it still seems like a reasonable change. Let's just check with the, we have a test page for custom properties, I know, but don't remember exactly what it's called. Properties, custom properties. Okay, so this should be purple. This should be pink. This should be green, cyan, 10px solid orange border, yellow background with a smiley, blah, 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 blah. Okay. And we shouldn't crash. Sure, sure, sure. All right, so based on this cursory exam of our test page, it works. Great. So I'm still gonna commit this because I like that it removes the nested rerunning recursively of the selector engine and turns it into a one-time cost at the start of the cascade instead. But it was not as impactful as I had hoped. Even though it felt a little bit better to type, it wasn't that much better. Like nothing to write home about yet. Sure, just a style tweak. libweb. Resolve CSS custom property cascade. Once instead of per property. Previously, we would rerun the entire selector CSS machinery, selector machinery for each property resolved. Instead of doing that, I guess because of the cache, we wouldn't redo it on parent elements. It would only be once per property, but we had it cached for every, like when we would go up the ancestor elements, we wouldn't rerun collect matching rules because of the cache on DOM element. So once per property, but still, that's still a lot, especially on a page like Discord, which has tons of these. We now resolve a final set of key custom property key value pairs at the start of the cascade. Yes. Sure. All right. So how are we going to filter these things? The easiest way that I know is to filter by the I don't know how to express this. Let me show you what I mean. So if we look at a selector here, like this guy right here, or this guy even, theme dark, and then has to have a descendant with this class. So this selector right here can only match an element that has this class, right? So any element that does not have this class, we can totally skip over this. We don't have to run the selector at all. So what we would want to do is sort all of the rules and all the style sheets we care about into buckets, per class buckets, specifically in this case. And then when we want to collect the matching rules for an element, instead of running every rule in the style sheet, we would just go through the classes in the element and run every rule in each of those class buckets. And I think the end result of that would be that instead of running 10,000 rules, you would run like 5 rules for an element, which should be substantially faster. The tricky part is just how to build up this cache and how to invalidate that cache. But it shouldn't be too hard, I think. The invalidation points are basically when you mutate, when you add a style sheet to the document, when you remove a style sheet, And when you mutate a style sheet through CSSOM APIs, and when the value of one of your media rules changes, so like if you change the size of the page and now like a media rule that used to be dormant or does not active becomes active, and like a different set of rules apply suddenly, so then you have to invalidate this type of cache. I mean, unless you keep media rules separate, but I think it's easier to just invalidate for now. And then we don't have to change the way we store media rules. So what we would want is essentially a cache. Well, let's call it a rule cache. And the rule cache would have class buckets. So it would be a hash map of a class string, and it would point to a vector of cached rule, I guess. So rules by class. What is a cached rule? Actually, it's a matching rule. It's one of these things, because that's what we end up producing. So yeah, so this is just going to be, this is probably the easiest way to do this. Yeah, so we just store a vector of matching rules for a given class. But the thing is that just because you have the class, it doesn't mean that this matching rule is necessarily going to match your element. It just means that you have to, this is a rule that you have to check because it may match. Yeah. Okay. So the thing to observe, I guess, is that let's write something out. So if you have a rule that looks, a selector that looks like this, then in order for this to be a match, it has to have all these three classes. But we don't have to store all the classes in a bucket. We can just store one of them. And when we visit this element to collect the matching rules for it, we'll check for buckets, the bucket for A, the bucket for B, and the bucket for C, and we'll find the rule. Even if like we have an element that looks like this, CBA, we'll still find this selector in our bucket. And yeah, so we'll have to, let's see, a little bit iffy on how we're going to do this. And then I guess we want to, how to invalidate this thing. Let's remember sort of, we can remember a generation or something like that. And whenever anything mutates, we just increment the generation. That could work. Cache generation. Okay, and then let's see. So then the document's style sheet list. Whenever you add a sheet to a style sheet list, we can do something like this. So like m generation. When you remove a sheet, increment the generation. That seems okay. So int m generation starting at 0. Let's see. And then I guess we should invalidate style for the document when you do this. So libweb dom document. And validate the style. That seems fair, because that will trigger a style update eventually. It will be lazy, like it will happen coalesced and on a timer, but it will happen eventually. Okay. And then let's start with that. And then style computer, collect matching rules. Let's see, we can start by only doing this for author rules, skipping over the default style sheet. So let's see, if the Cascade origin is Cascade origin author, then we can do our own little fast path here. So I guess we need a backup bucket as well, which will just be a vector of matching rule, like other rules. So every rule goes in one bucket, and these are all the rules sorted by class. And then here are rules that didn't have a class. So like the remaining rules, essentially. Okay, so for auto class name in element class names. Then we want to copy over all of the... Actually, the first thing we're going to do is figure out which rules we need to run. So these are not necessarily matching yet. I was getting ahead of myself here. Let me not get ahead of myself. We need a vector matching rule, rules to run. Okay. And again, I guess we could use a pointer here because then we avoid copies. So be a little bit nicer. So we have rule cache. Wait, did I not make a rule cache? Oh, I just declared a struct. Yeah. So I just wanted to put these in a struct just so we can keep them sort of bundled together for now. So rules by class. If auto it rules by class. Class name. Rule cache. So we have rules for this class. Then rules to run dot extend. Oh no, these are going to be referenced. Okay, let's just use copies, just for simplicity for now. I shouldn't get ahead of myself with these micro optimizations. Rules to run extend it value. Yes, there we go. So we copied over all of the rules from each class bucket. Great. And then we also have to copy over all of the non-specific, like other rules. Yeah. Okay. And then we'll run all of these rules. So rule to run and rules to run. Selector is rule to run. We have the selector index. So I guess rules selectors rule to run selector index. Okay, that's our selector that we want to try out. And then we just want to run it just like we do down here. Essentially the same idea, but instead of constructing a matching rule object on the fly here, we can just pass in the one that we have. So rule to run goes in if it was a match. Let's see. That seems really reasonable. Yeah, so for author style sheets, meaning stuff from the web content itself, not from our default user agent style sheet, we go through all of the class names in the element, And for each of our rules by class buckets, we copy over all of the rules to run from that bucket. And then we also copy over all of the other rules that are not in a class bucket. And then we iterate through all the rules to run, try running the specific selector. If it matches, we add the rule to run to the matching rules, and then finally return the matching rules. This feels correct. So now we have to produce these buckets, which means we have to essentially do this, what we were previously doing, but in some kind of a cache building function. So I guess something like style computer build rule cache or something like that. Or maybe like update rule cache, build rule cache. Let's call it build rule cache. Okay, so first thing we're going to do is we're going to say m rule cache. We just kill it. Okay. And then finally, we want to say m rule cache generation is document style sheets generation. Can we read that from here? No, we cannot. It is not public. Maybe we should also have a increment generation helper that we can call from elsewhere. Or maybe we can call it bump generation. It just has to plus it for now. Okay, so in this case, I guess we can hard code that it's for author rules only for now. Fix me. Support make a rule cache for UA style as well. Yeah, it would be nice to have one for user agent style as well. But for now, user agent style doesn't have any classes, so there's no gain from it for now anyway. But there will be gain once we add other types of buckets, I guess. So let's see. What do we want to do here? Instead of running the selector, we just want to classify it and then put it into a bucket. So we are here. So this is what we would put into the matching rules if it matched. This is a matching rule. Sure. So what we want to do is, let's see. We want to take that matching rule and then insert it into a rules by class bucket. We have to figure out what is, I guess we can just look at the first class component of the simple selector set. So if you're not familiar, selectors can obviously have many separate parts. So if you have something that looks like this is a, what is it called? A compound selector. So this here is this is one compound selector, this is one compound selector, and then you have an invisible descendant combinator between them. And I think these are each one simple selector. So the simple selectors are glued together. In this case, these all apply to the same element. I think I'm getting that right. Simple selector. Yeah, so a simple selector can have like a tag name, an ID, a class, attribute, and so on. So these are three simple selectors. Sure. And a simple selector is part of something bigger. So a selector is a vector of compound selector. Compound selector is a vector of simple selector with a combinator, optional combinator on the left-hand side. So a different one might look like this, right? This is also, we have a vector of complex selectors, vector of compound selectors, sorry. This first compound selector has one simple selector, then there's a child combinator here, and then we have another simple selector with a tag name. I think we called it, right? Tag name? Tag name, yeah. We could definitely make buckets for tag names as well. that would benefit our default style sheet, which works largely on tag names. Could definitely imagine reducing the number of rules to run from doing that. Anyway, so we have to iterate the rightmost compound selector, because these, like anything but the rightmost one is irrelevant, because this is the only one that refers to the specific element that the whole selector is targeting. So we want to filter on this part here. So selector, let's see. Selector, I'm gonna use this so I get some help with the auto completion. So simple selector in selector dot compound selectors dot last. Yeah, because I only care about the last one. And I want to iterate his simple selectors. There we go. Okay. So if simple selector type is CSS selector simple selector type class, then rule cache rules by class ensure simple selector value append move matching rule. Okay. And then we can break out of the loop. And then let's see if we didn't add it anywhere. Okay, I guess we should say something like this. Added to bucket false. If not added to bucket, then mrule cache other rules append move matching rule. Yeah. Okay, let's try this. I feel optimistic, but it doesn't build. Oh, because nobody calls build rule cache, and I didn't even declare it. Yeah, that was too optimistic. Okay, so who's gonna call build rule cache? I guess we can do something like this. Build rule cache if needed. And then compute style will do that. So build rule cache if needed. And this will be a little bit ugly. Or no, it doesn't need to be. Actually, we can make that const, and then it's a little bit ugly in there instead. Is there something missing here? Yes, there was. Okay, style computer, build rule cache if needed. If rule cache, if. Maybe we should store that in a heap allocated object instead. That seems fine, and then we can just wipe it. Then we can have a way to invalidate by throwing it away. So here we do something like this. Yeah, this will be cool. If no rule cache or rule cache generation is not document style sheets generation. Or no, if we have one and they are equal, then we should return. That's what we should do. Otherwise, build rule cache. And this is where we do the const cast, because somebody is calling us from a little const place. Okay. Return to optimism. Maybe premature. I need to fix a bunch of these. Not super many, but some. Oof, okay. I am generally optimistic about this. There's definitely a lot more copying and we could be a lot more memory efficient. But for a first attempt at this type of bucketing optimization, I think this feels reasonable, feels pretty healthy. We should probably print out some stats actually after we build this cache. So we could print out here, built rule cache, and then debug line, class rules, class rules. Let's see. I don't know. I need to put this number somewhere. Num class rules. Okay. I guess we can just say class. Rule cache, other rules, size. Yeah, that'll be interesting. And it would also be interesting to learn how many rules we are actually running here per element. Cast element. I wish I knew how many rules there were total. Okay, I want more information. I should have dumped out the total number of rules here as well. Or I mean, I can also just compute that, but num class rules plus, yeah, whatever. We can add that output. And then we have some clue of how many we're avoiding to run. Okay, let's see if the welcome page works. It crashes. Great. And everything crashes. Sure. So we built a rule cache, 1 class rule and 7 other, and then we failed somewhere. A ref putter, and then we try to respawn the web content process so fast. I think we can do a little hack here. So if we crash, we'll just go to sleep instead of spawning a new web content process. We need to have some kind of mechanism in the browser where, like, if the web content process is crashing too fast, we shouldn't try to create new ones over and over. Because I just want to see the crash report instead of like totally killing the machine. All right, so what's wrong? Style computer, collect matching rules. And where are we? Collect matching rules. Style computer 84. We did something wrong. Rule to run. Rule. Okay. Is that a null pointer? Rule to run. Wait, why is it? Why would that be null? I'm making it here. I'm moving it here. And if it wasn't added to a bucket, I'm moving it here. Oh, but I never set added to bucket. Oh, yeah. Okay, that was a silly mistake. There's probably a way to write this code nicer so we don't have to have like added to bucket. But, Okay. Totally renders. What about acid 2? Looking beautiful. Okay, so basic stuff works. Let's look at Discord. 0 rules. Oh yeah, we have all this debug output. Forgot about that. 543 rules against element. My goodness, that's a lot of rules. But how many are we not running? That's what I want to know. What did we say? Total colon. Total 16,822. So we have 16,279 class rules. And now with the bucketing, we can avoid, as you can see here, like in many cases, we're only running the other rules, presumably on elements that have no class at all. Which I guess you wouldn't see here, but if you open up the DOM, also the page looks wrong, by the way, but we'll get to that. Oh, that hangs. Why does it hang? I don't know. That's a little bit alarming. Okay, so the page looked wrong. Let's see if we can see something here. Okay, so the inspector clearly works. And this page has no variables, but what if we open res.html misc see custom properties? Yes. Okay, so this page has custom properties. And if we open up one of these test boxes, click on variables, we can see them. Very cool. Okay, yeah, so you see the actual like final resolved cascaded values here. That's what we were fixing up in the web content client connection code, I guess, so that we fetch these from what we cached on element. All right. There was that custom property resolution tuple. I think we can get rid of that. Should have just gotten rid of that already. That should have gone into the previous commit. Let's take care of that. Then a rebuild, but yeah, so the page didn't look quite right, which probably means that there's some dynamic mutation that we're not taking care of. So we need to invalidate in some other case, because I only added invalidation for adding and removing style sheets, but we didn't do any media, like these media query rules, whatever, media, they're called media queries, right? Or are they media rules? Media query. Add media rule. I mean, they had those here, right? Media, yeah. So I think we have to react and invalidate the thing when these change. So evaluate media queries. Who calls this? DOM document. Evaluate media queries and report changes. This sounds really, really relevant. So, okay, so, and then who calls this? The event loop. For every fully active document, evaluate the media queries and report changes for that document. Okay, and so then we iterate through all of the media query lists known to this document. And then we also evaluate all the media queries in style sheets. What does it mean to evaluate them in style sheets? We visit every rule, and then depending on the rule type, for media rules, if, okay, so we try to evaluate it, and if it works out, then, wait, what? Evaluate media, oh, so then we traverse into it. So I guess what happens here is that the state of the rule is then changed, or no? Oh, this is my recording. And that was not the right key press. the state of this thing. Who sets the state of media evaluate? This is not const. Why is this not const? Could it be const? No, media evaluate is not const. Why is it not const? Because it remembers. Okay, I see. So this machine here goes through all of the media queries in all of our style sheets and then evaluates them. And then in the case that they change state, they remember it from this point on, which means that a different set of style may apply. That's a little bit goofy. Because this thing doesn't really report that anybody changed state. So this is a little bit janky, but what if we just bump the generation of the style sheets right here? Like when this happens, which would force a rebuild of the cache after evaluating media queries, which it will invalidate too often, right? So maybe bump generation actually is not the right thing to do here, but rather we should have a way to, as we talked about, style computer invalidate rule cache. Yeah, that's what we really want to do. But since that API doesn't exist yet, let's just try what happens if we bump this generation, which effectively accomplishes the same thing. So I think this should cause media queries to, yeah, exactly. So takes quite a bit of time to repaint. So let's get rid of that. Also, let's put a big fix me here, and then we want to get rid of that debug output. So this invalidates too often. We should only validate when one or more media queries, media rules changes evaluation status. Yeah, that's too aggressive for sure, but I'll leave it to our future selves to figure out how to do that, because we have to somehow learn that at least one media query either used to match and no longer matches, or didn't used to match and now matches. But invalidate rule cache. Okay. And then we will call that style computer invalidate rule cache. Rule cache is gonzo. Why don't you like that? What? Can I do that? Yes, I can. Okay. Okay, and then running rules against element. Let's get rid of that. But yeah, 543 rules per element is substantially less work compared to 16,000 whatever rules per element. So I would imagine that we should see should finally see a substantial reduction in time spent in compute style. And I think there were definitely other approaches we could take to this, doing like a more targeted optimization for text inputs, but I like that we're taking this approach first and just making all CSS selector matching do less work, because this benefits every page and not just the typing into a text field case. We should, of course, optimize text inputs as well, but I feel good about this thing. I think this will be really nice. Also, I'm tempted to add bucket by ID and maybe bucket by tag name, but this thing doesn't have a whole lot of other things. Look here, this here would be bucket by IMG tag name, right? So this one would go in a special bucket and you don't have to run it for anything, any element that's not an IMG element. That would be the benefit. This one goes in a strong bucket. There are not so many. I guess you could do like other specialized buckets, like a hover bucket, where anything that only matches if it's hovered, you can put into a special hover bucket. But it's pretty rare. Ultimately, you have to kind of decide which types of buckets you want to keep track of, because obviously there's such a thing as too many pointless buckets that never get anything in them. All right, let's see this. Build rule cache. So yeah, so the rule cache now builds too often, for sure, but it's not super expensive, so it's not the end of the world. But we should definitely figure out how to do less of it later on. Okay, so let me move the cursor. Okay, and then let's try to type. Oh yeah. You can actually see the text coming out. It's not perfect, but it's a huge improvement. Okay, so let's profile this. Oh, crashy. Okay. Oh, just checking. My phone is lighting up for some reason, but nothing that can't wait. So let's see. Now I was actually typing 4 times per burst instead of 3 times as before, but even so, I think like you can visibly see how much faster it is, right? So it's not a big deal. So what are we doing in one of these bursts? We are now painting primarily. 52% in page host paint. That's great. Where is compute style? Compute style, 39%. Okay, so we are down from 83% to 39% in compute style, I think. Huge improvement. We can definitely do better, but this is already great, really great, I think. Yeah. Super duper good. Very pleased with that. Build rule cache here, 5% in build rule cache. That's not terrible. In the great scheme of things, 5%. We can definitely get that down further by invalidating less often, but this is okay for now. Yes, and then we can definitely do less layout in response to text input and blah, blah, blah. But if we look at what's dominating this now, it's painting. And painting specifically does... What are you doing, paint? SVG path. Okay, so SVG path paint. I think we saw this before. The anti-aliasing painter used to draw the SVG paths on the page is expensive. And I'm sure there are strats we can use to improve that, but I think I'm going to round it off here. I'm pretty happy with what we've been able to achieve today. So let's commit what we've made here. And let's also get rid of things that we didn't want to keep. I think that crash hack where we go to sleep after a crash. Yeah, okay. So let's see what we can commit. We don't have to log build rule cache. I mean, unless we have style computer CSS debug. I think we have something like that. Debug H. And let me increase the copyright date. Wait, don't we not have? Oh, it's libweb CSS debug. My bad. There we go. libweb cache cache CSS rules in buckets to reduce number of rules checked. This patch introduces the style computer rule cache, which divides all of our author CSS rules into buckets. Currently, the only bucket type is there are two buckets. Rules where a specific class must be present. All other rules. This allows us to check significantly smaller set of rules for each element, since we can skip over any rule that requires a class attribute not present on the element. This takes the number of typical number of rules tested per element on Discord from 16,200 to 550. Let's say 16,000 to 500. 550. Yeah. Rounding the bad number down and the good number up. Super fair. Yes, I think that's pretty cool. I'm not 100. Yeah, there's probably, we can definitely improve cache invalidation. It currently happens too often due to media queries, and we also need to make sure we invalidate when mutating style through CSSOM API. Yes, but that does work really nicely. So super cool. I am very pleased with this. let's test some other page just to make sure that I didn't screw everything up. So we already have it running here actually. So just close that out. And where do we want to go? Let's go to Bjarne's website. Look at it. Magnificent web design right here. That's all good. Acid 2 looking good-ish. Acid 1 looking great. Let's check jcs.org. Okay, some rendering issues for sure, but looks about as good as it usually does. That gigantic RSS SVG in the background, I think that's supposed to be really small. Like a tiny little thing. Yeah, this guy right here probably has an SVG view box, and we are just bloating it up like crazy. Anyway. Yeah, great progress today. So this will be where we end the video, because now my brain is tired and I have to relax. But if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here today and maybe learned something or got some interesting ideas. The project to get Discord working on Serenity continues, and everybody is definitely invited to hang out with us in the browser channel on our Discord server, where people are discussing next steps and other things that we need to implement in order to improve support. And big shout out to everybody who's been helping out with the investigation. Really appreciate all the help. That's so cool. Very hype. Thank you for watching, and I will see you all next time. Bye.